Hey everybody, it's great to be back at Utah JS. It's been a while. It was kind of weird the last couple of years. Who knows why? Anyway, we're going to be talking about establishing flow today. And by that, I mean a particular definition of it, not the sort of state of individual flow that we're probably all familiar with, more so on No Meeting Thursdays than other days, of course. But first of all, I realize that you have other choices besides sitting in here for the next half hour, including but not limited to going into the hallway and just staring at the wall. So my gift to you is to help you understand if this will be a useful talk for you to start with. Do any of these stats or symptoms, however you want to call them, feel familiar? At least in spirit, maybe not the quantity, but 46 PRs waiting to be reviewed at your org. Average time to get a PR reviewed, 4 days. Average lead time for a work item, so when you start working on it to get it deployed into a production-like environment, 7 days. Change defect rate of 10% plus, so 1 out of every 10 deploys has an error. Or maybe the time to onboard a new team member to get that team member feeling productive is around 6 months. Does that strike any sad chords of familiarity with anybody? Yeah, been there too. All right, before I dive in though, who am I? Why should you care what I have to say? Ethan Garofolo, cool Italian last name. I mean, if that doesn't convince you, I don't know what would, but I help companies achieve flow, currently doing that as a systems architect at Omni, and we're hiring. We are a venture capital analytics company, so we help venture funds make sense of their investments, and we're doing cool stuff. Check out omni.fund/careers if you're interested, or find one of us wearing one of these shirts here today. We'd be happy to talk to you as well. You can find me on Twitter, on Twitch. I have a mailing list, and like Tanner said, I wrote a book about microservices, which, if you've been here in the past couple of years, you probably know me as the guy who won't shut up about microservices. That's not going to change today. And as long as Utah JS will have me at this conference, I will keep milking this slide. That's still no moon. After all these years, it's still not a moon. And usually what I do is I put that up there, and microservices is the big circle, and whatever the topic of the talk is the little part in purple. But in Soviet Russia, microservices are the Russian reversal doesn't work for Venn diagrams at all. So don't try that in your own work. Anyway, we're talking about flow. And the reason that I'm a big proponent of microservice architectures is because they are part of enabling flow. They're not an end in and of themselves. They are there to make it so that your code base isn't the thing preventing you from achieving a good state of flow in your system and in your development processes. So there's something else I don't shut up about, and that is let me just grab the physical copy here for effect. The DevOps Handbook, fantastic book. Highly recommend it. It talks about the 3 ways of DevOps. It's by the same folks who wrote the Phoenix Project, if you've ever read that. And one of the big takeaways I got from it was I hope this doesn't these ain't fighting words, but if you've got a team called the DevOps team at your organization, there's a chance that you've missed all of what DevOps could bring to your organization. It's a methodology, it's a way of organizing the work. And the 3 main principles that the book talks about are, first, flow, which is what we're talking about today. There is feedback and continuous learning. What are those? Flow is the ability to take something smoothly, regularly, from inception through development and get it into a production-like environment. And then once stuff is deployed in such an environment, feedback is being able to get information back about that deployment while it's running. So things like pervasive production telemetry, analytics to make sure it's meeting your business objectives, stuff like that. And then these 3 ways culminate in continuous learning. What would that look like at an organization? It's the ability to turn local discoveries into global improvements. So if one team discovers something that could help the work, is your organization set up to be able to spread that knowledge and incorporate it back into the daily work? In the book, they talk about the key differentiator between high-performing teams and their less high-performing counterparts is high-performing teams make improving the daily work the daily work. That makes sense. So constantly making things better, looking for improvements and actually putting them into practice. I like to phrase it, if you focus on acceleration, velocity will take care of itself. And by that, I don't mean velocity like story points and that kind of stuff. Don't get me started on that. But I mean velocity in like the physics sense of the term, being the first derivative of acceleration, if I'm doing my math right. Daniel said earlier that humans aren't very good at math. I'm a human, so you can finish the thought there, I suppose. Anyway, cool photograph from the book right there that I forgot to show. Oops. But yeah, dev goes to our production operations. And so this concept of DevOps, the principles behind it were not unique to software development. They were first noticed in manufacturing. If you're familiar with lean methodologies at all, Toyota production system and such. And then some people apply them to software. And where DevOps comes from, the book talks about is that in a typical organization where you have a development organization and an operations organization, there's a conflict between those two groups. What do developers want to do? We want to change things. We want to deploy things. We want to get work done, push it out to production. And ops wants to do the opposite of that because their goal is to keep things stable and functional and operational. And in a lot of places, they report up different parts of the hierarchy. So there's a major conflict there. And they said, why organize it that way? Why don't we recognize that these are the same teams? And who was it? I think it was... Garrett was presenting in here a moment ago. He asked the question, when a bug makes it through to production, whose responsibility is that? And I think that's a really good question. Is it QA who missed it or developers who put it there? Why pit those two groups against one another? Are they not all engaged in the same effort? Are they not part of the same team? So that's the spirit of DevOps. That's what we're trying to achieve with it. Tooling that DevOps teams tend to build enables that in the same way that microservices enables that. I really think everybody should get this book and read it, but if you do, heads up, this is an actual offering on Amazon. It's called DevOps Handbook, not the DevOps Handbook. This one's by Henry Martin Jones. That is chutzpah, which is a Yiddish word that means cojones. Like, seriously, my hat is off to the author of this book. I have worked in development my whole life. I am not a marketer or branding expert, but like, I've seen enough cop TV shows to know that there's no such thing as a coincidence. And that's just amazing. I am seriously in awe of someone who would be willing to do that. So if you get the book, make sure it's the one by Gene Kim et al. Et al. Being the most prolific writer in the world. Anyway, achieving the 3 ways of DevOps, there are some passages of what an organization that operates like that would look like. And I love this vision. It's from the introduction of the book. It says, in this scenario, everyone feels productive. The architecture allows small teams to work safely and architecturally decoupled from the work of other teams who use self-service platforms that leverage the collective experience of operations and information security. Instead of everyone waiting all the time with large amounts of late, urgent rework, teams work independently and productively in small batches, quickly and frequently delivering new value to customers. I just love that vision. Who wouldn't want to work at that place where you're constantly getting work out, you're seeing the results of your work make people's lives better? I think that's a real ideal to strive for. And then specifically of the first way, it goes on to describe the characteristics of that. The first way enables fast left-to-right flow of work from development to operations to the customer. In order to maximize flow, we need to make work visible, reduce our batch sizes and intervals of work, build in quality by preventing defects from being passed to downstream work centers, think Garrett's talk, developers to QA, and constantly optimize for global goals. And by global goals, we don't necessarily mean the entire Earth, but within your organization. Because it turns out that individual goals, individual priorities can be an impediment to achieving the global goals that we're trying to achieve. Those are the intro slides. How are we doing on time? We're doing great. It's demo time. And I imagine that there would be empty seats down here. And so we'd have to take a few minutes to ask some volunteers to come on down. I'm going to turn this camera on up here. So if you're in here, I would appreciate if you'd be willing to be the people who do this demo. So I'll put this up real quick. And then maybe it won't let me make that bigger. That's a shame. Let me slide this over because we'll need this as well. Oh, let me not spoil a meme. Like, that's good stuff right there. Put this here. Okay, so who do we have? Let's see, 1, 2, 3, 4, 5, 6. Holding the camera. Remind me your name, I'm so sorry. Blake, that's right. Okay, let's say Blake, Jared, I don't know, Robert, and Bruce, and Luis. John, are you 6 willing to be our happy volunteers today? Okay, fantastic. Could I ask one more favor? We need a space, a seat between these two sides of the team. So would you all mind shifting one seat that way? Thank you so much. And we're going to play a little game. Games are fun. And I need to bring some supplies over here. But let me put up the next slide, which, is that font big enough? I'm going to skip the photos for right now. We're going to play something called a variant of the envelope game. And so, I mean, this was for calling people down, but you're already here. But let me verify, are you 6 all capable of writing, putting folded paper into envelopes, operating a sticky note, and or pulling paper out of envelopes? Fantastic, then we are good to go. Let me bring up the next slide as well. We have 2 teams working on brand new software projects and trying to soak up market share. So we're going to have a product manager, a developer, and both teams will have that. Let's see, you would be the developer, and you would be the product manager. Okay, now I need to get the rest of the implements that we'll need here. Sticky notes for you there. I actually am going to need one of these real quick. Would you mind? Thank you. And then you'll all need Sharpie markers. All right, cool. That's all distributed. Now here's how the game goes. Product managers, there's 2 teams, by the way, and you can't see the teams. All right. Is that legible? No? Okay, folks in the back aren't able to see it. Maybe I can slide it a little bit bigger. No, I don't think that's gonna work. All right, let me flip over here real quick. So the folks on the right of the image, that's gonna be team SPF. Sounds like sunscreen, but that's not how we mean it. And over here is team batch. And here's what's gonna happen. The project manager is gonna take an envelope and write numbers on it, starting with 1, but not yet, don't start yet. Going through however far we get. We want to get at least 10 features deployed to production here. And so the product manager will write the number on the envelope, and then those will get passed to the developer, who will take the folded piece of paper that they have, write the same number on the piece of paper, stuff it into the envelope before passing it on to QA, who will take the paper out of the envelope, verify that the number matches what's on the envelope, and then finally deploy it to production by setting it on the tray right here. So team batches, deployments here, and team SPFs right there. Does that make sense? Any questions about that? Now here's the hitch. There's always a hitch, right? Team batch, you have to do 10 before you can pass them down to the next cycle or the next station. So you're not allowed to pass anything along until you've got a batch size of at least 10. And Team SPF, you must do batch sizes of 1. So you'll do 1, pass it over. You can start your next one, but you can't do another one until Jared pulls the first one from you. Does that make sense? So you're never going to build up any envelopes and so on and so forth. Obviously, you're not waiting on a station. You just put it there whenever you're ready. Okay. That's the deal. That's what we just covered there. So in your minds, think about who you think will win. Team batch, will their efficiencies carry them to victory, or will Team SPF prevail? I totally wish I had some cool music to do this. Oh, and then there's one more hitch. I think it's on the next slide. At 2 times, I'm going to interrupt you all to give more information, more instruction. So when I say stop, freeze wherever you are, and I'll give the new direction, and then we'll resume, okay? Right? We want to capture the unknown world of software development right here. Let me put this up, and let me slide this over. I'll do my best to capture these stats, but it's kind of hard to do with one hand tied up here. And I don't have the names here. That's unfortunate. But these are what I'm going to try to capture here. So ready, on your mark, get set, go. All right, we have our product managers writing their features down. Team SPF has just finished developing their first feature, and it has been passed to QA. Oh, I'm sorry, there was one more thing. You're supposed to write the number on a Post-it note and put it on the paper as well. My bad. Yeah, QA is supposed to do that. Those are your test cases to validate what the developers have done, and then put it back in the envelope, yeah. So let's see. Team SPF has their first feature deployed. Oh, the camera messed up. What happened? It froze. Click photo booth to resume. I see. If you don't leave the application with focus. Thank you for calling that out. Okay. Yes. This is great. All right, second feature deployed to production for Team SPF. We can see that Team Batch is getting the test cases written out. The developers are furiously working on their tasks, clicking through them. This is good stuff. We almost have feature 4 out to production. And pause, everybody. There's been a change in our requirements. Feature 3 has been out in production, and we found out that if we tweak it a little bit, it will sell better. And that's what we want to do. So it turns out the customers don't want the numeral 3. They want the English word 3 spelled out on the paper. So each team, if you've deployed it, send it back through the work process and then back through the development pipeline. And if you haven't, however you want to get it done. But the envelope has to get back to the product manager and then go back through the pipeline. Go ahead and resume. So Team SPF, yep, there you go, exactly. Has fixed it. The developer's pulling it back out to update it. We got the batch of requirements back to the product manager over here on Team Batch. And QA just received the updated work over on Team SPF. And feature 3 is back in production. Way to go, Team SPF. All right. One thing that's really interesting about this, having seen this sort of a demo before, is how the size of the tables that we all have on our chairs affects this. I'm sure Team Batch will have much to say about that when we're all done here. All right, Team SPF just deployed number 7 into production. And the developers are still working on Team Batch. Feature 10 just got developed for Team Batch. Works on his machine, then we'll ship his machine. And that is how Docker was born. Totally ripped that off from a meme. All right, Team Batch just deployed feature 10. Team SPF has deployed feature 10. Looks like 11 is into test. Yeah, you guys can keep going until both teams have shipped 10 features at least. Stretch goals, exactly. The Kickstarter campaign was overfunded, and so we're going to deliver on that. Sorry, I bet on the camera you can't see the specific numbers. You just see these fine individuals toiling away. Thank you, teams. Oh no, screensaver. Oh, thank you. That screen is totally saved. Strong bad, I'm sorry. I was alive in the early 2000s. All right, how are we doing? Feature 1 from Team Batch is about to go out just as Team SPF ships feature 15. And Team Batch is about to do feature 2, and that's where we will pause, or stop rather. Okay, let's go ahead and stop right there. Let's give a big hand to our volunteers before we ask them questions. I didn't capture the stats, although, let's see, we can get some of them. Let's say 4 minutes passed. What just, wow, that was neat. I promise I know how to operate a computer. That was, oh my dear goodness. What at 10 is batch and binary. Exactly. Team SPF, what was your feature count? 16? Okay, cool. So you deployed 16, and I think I reversed these. No, I didn't. Woo, one thing went right. There we go. So we could just do this one divided by that one. My physics teachers would be so mad at me not including units in any of this. But we can see that the SPF team, no, those are defects. That's not what I meant. Let's just rename this real quick and call this frequency. So, no, that's still not, whatever. Team SPF did more in the same amount of time. That's the essence of what we're talking about here. And I forgot to stop things the second time. That's all right. Reactions. I am not surprised at how this turned out. So, what were some of the frustrations that you felt over here? Whoever wants to.
It took forever to get all 10 in the envelopes.
Yeah.
And he had to wait the whole time for me. Anyway.
He did have to wait. He was able to do some things in the meantime. I saw, Bruce, that you had written out all your test cases before the batch got to you, but there still came that moment where you couldn't do anything. Talk to me about the size of the tables that you were working with.
Not big enough.
Not big enough, right. Your inventory exceeded your ability to deal with it, right? So in manufacturing, that kind of thing is really obvious. If you're at a physical goods processing plant, it's pretty easy to spot inventory. You look over there and you see a Jenga tower, and it's like, oh, that must be inventory. We don't work in a factory. We don't work on a manufacturing line. What is our inventory in software development? What was it? Backlog, exactly. That's an example. What else? Pull requests. Code developed but not yet reviewed. What if the code's been reviewed and you're waiting on QA to do it? That's inventory. 5 min. Okay. I wasn't supposed to say that, but I did. I've got 5 minutes left. Yeah. But these are some of the challenges you get when you get bigger batch sizes. Team SPF, or both teams actually, the question when the new requirement came through to write the word 3 out instead of using the number 3, how would you say that affected your workflow, Team SPF?
It did not affect it much.
Did not affect it much. You were able to adapt to the new requirements very quickly. SPF, by the way, stands for single piece flow, which is the ideal theoretical limit of reducing batch size. Team batch, how did that requirements change affect your workflow?
We're still in the development process, and so I had number 3 right there, so I just had to pass it back.
Okay.
It threw the envelopes out of order.
Yeah.
It threw the envelopes out of order because the inventory had piled up so much it was difficult to deal with that. Yeah, exactly. Would you believe me if I said I've never actually run that simulation with people? You know, in all the lawyering shows, they say never ask the witness a question you don't know the answer to. I've never run this simulation before. That's how confident I was in what the result would be. So I think there's some interesting lessons to take from that as regards software development. So we talked about that question. Another interesting question, what if there had been errors? Say, what if I had written the number on the envelope and Jared, you hadn't been able to read it, or vice versa over here? When would the developers have found out that there was something amiss with the requirements? After it was all written, after the entire batch was done. Whereas in single piece flow, you would have done one, passed it on, and found it out immediately. So that's one of the important reasons to have good flow established at your company, so that you can get feedback a lot faster. There is a line that I've heard, I don't know where I first heard it, but it was that if you send me a 100-line pull request, I'll find 4 bugs in it. But if you send me a 1,000-line pull request, looks good to me. What are the things that discourage us from sending smaller batches downstream? Because the size of the pull request is a batch size measurement. We would want smaller ones. What prevents us from doing that? Lack of feature flags, so we don't have the tools in place to support rapid deployment. And what happens if you've got a 4-day wait for a pull request? What does that incentivize you to do with your pull requests? Yeah, stuff things in them. My favorite example of this, got a little bit less than 2 minutes, was I was at a work conference and there was a buffet line and they told us you get 1 trip through the buffet line. So take 1 plate. What did that incentivize everybody to do with their plates? Mount food, right? And it's the same thing. If it takes a long time to get our pull requests reviewed and get them through, then we make them bigger, which in turn makes them take longer to do, which in turn makes us make them bigger, and so on and so forth. So we'd want to look at strategies to eliminate the need for them or make them smaller, somehow get the processes flowing so that we can get smaller increments of work out faster. Surely I said something that someone hears and is like, I want to make a comment about that. You have about a minute. I made other slides, but I was anticipating we would just have discussion at the end. Any thoughts about this? Was the experiment unfair? Was it stacked against Team Batch?
If it was run longer, maybe Batch would have a better chance.
It's possible. It would be interesting to investigate. I've seen people do this experiment with 1 person, and 1 person doing the batch processing still is slower than 1 person doing single piece flow. So I don't know how it would turn out. It would be great to run the experiment. I'd love to do that, but clearly we're out of time here. But yeah.
So, just like curiosity, if the SPF had to write instructions on every single piece, like how to test, how to deploy, versus batch had to write instructions on one piece for the entire batch, would that affect it a lot?
Possibly. If the work items were also similar that they could do that, yeah, probably. So that would be changing the nature of the work. That's a possibility. There's one last thing I want to show here. Fine, this is the meme. We get the meme. The focus is on completing work. I'll just let you read this because this speaks to me about the importance of small batch sizes and finishing things before you push new things out. Thank you all for choosing to not stare at the wall for the past half hour. Have a great rest of the conference.